class, welcome to today's lesson. I'm Mr. Kevin Jagi from the School of Computing. The unit is Introduction to Network Devices. And in this particular unit, we are going to learn the various types of network devices that are used to link the computers together. Which devices are used to link up networks, various types of networks that exist, and what are their functions. It introduces you to the knowledge of specific devices that we use to link computers together. The topic is on Introduction to Network Devices, and first of all, we'll understand what is a computer network. A computer network is an interconnection of two or more computers and the associated devices for the purpose of sharing resources and for communication in a network. And for that purpose, you can link up several devices in a network such that all these devices and components can be able to participate in a network and be shared across the different users in a network. You can share a printer to a community of network users, different computers in the network. You can share a storage unit like a server. You can share a scanner. You can share software materials or software resources that are stored centrally somewhere in a server. And that way, you achieve the objective of networking, sharing resources, both hardware and software, and for the purpose of communication. So when you set up a network of any nature, whether it's a small network or a large network, you require network devices. And therefore, in this particular class, we'll be able to understand what is the function of each and every network device that we use in a network. From this simple network that is demonstrated here, you can see there are quite a number of devices. So the size and the purpose of your network determines the hardware components and the hardware devices that you use in a network. There are different types of networks that you can set up, and you require different devices. So these network devices, they are components that connect computers, all electronic devices, to a network, so that resources can be shared, just like printers, the scanners, the disk for storage, software resources like data files, programs or softwares, and so on. They can be shared across the network. So we have quite a number of those network devices, like the repeaters, the bridge, the hub, the router, and so on. You can set up different network connections. We have a peer-to-peer network connection. We have a server-based network connection. So this determines the kind of network devices that you require at a particular instance. And again, the size of your network, whether it's a peer-to-peer or a server-based network, also determines whether you require additional devices so that they can perform other network management functionalities as required within your network. Where you have less users, there is less data traffic. Where you have more users, there is a lot of data traveling. There's a lot of data traffic. And therefore, in such a case, you require to manage your network in a much better way using additional devices. And you are going to look at each of those network devices. When you set up a peer-to-peer network, it means that in this network, the computers are of the same type. The resources are being shared by devices that are of the same capability. There is no control from one computer to the other. Each user controls what you want to share on the network across other network users. So this one is suitable for a small network, but again, you require few network devices to set it up and even to manage it. There is less data traffic, there are less users in the network, therefore you require few devices. It's quite cheap to set up and operate, though it has other disadvantages in the sense that it's not suitable for large networks. Again, it is very difficult to manage the specific resources that are on the network if you use this kind of a network setup. If you set up a server-based network, then it means that there is a server which is managing the resources across the network. And a server-based network depends on what you are sharing across the network. You'll require to use a server that is configured to share a specific resource. If you are sharing a printer, you require a print server so that you can configure it to be shared among the multiple users within that network. If you are sharing files and data, you require a file server. If you are sharing a storage space within the network with multiple users, where each user has a space to store their data, then you require a disk server. And again, if you are sharing a database application, you require a database server. So database network connection depends on what resource that you are sharing across the network, which determines the kind of server that you require for that purpose. There are quite a number of the network devices, which includes terminals, workstation, client computers, server, network interface card, transmission medias, among others like repeaters, bridge, brouter, gateways, and so on. But each of these components, each of them has a specific function. And the choice of one depends on the functionality that you want to add to the network, or the kind of management that you want to add to the network. If you have a lot of data and you want them to be directed through specific routes that are suitable for data transmission, you require a router. If you want to segment your network into sections such that data packets can easily move across the network, you require a bridge. So each of these hardware components, they have a specific function. We are going to look at those network devices, but before that, let us look at the classification of those network devices. The ones that you have mentioned, they're either classified as networking devices or inter-networking devices. And the difference is that networking devices, the devices that are used as networking devices, they are used to manage a single network, either by extending the network or by segmenting the network, but a single network. If you have a simple network for a single organization, like Mount Kenya University, they have a local area network. To manage that single network and to expand that single network each and every time you're adding computers to the network, you require networking devices like the hub, the bridge, the switch, the repeater, and so on. But to interconnect multiple networks, you have network A, you want to connect it to network B for another organization or for another company with another network C, you require inter-networking devices where we have routers, brouters, gateways, and so on. They are referred to as inter-networking devices. So these are devices that are used to manage a single network. These are devices that are required to manage multiple networks or internetworks. We are going to look at each one of them briefly and learn to understand the function of each. We'll start with networking devices, then we look at inter-networking devices. We have said these are the devices that are used to expand a single network. If you start or you set up a network within this institution, you may start with, let's say, 10 computers. And with the time, as the organization grows, new offices are created, you add computers into the network, and over a year or two, you find that you have 40 computers or 100 computers. That network is growing each and every time. You require these devices to expand your network. You require the hub, you require the repeater, you require the bridge, you require the switch. They are referred to as networking devices. Expansion within a single network. And to do that, you require those devices. What is the function of each of those devices? For instance, the hub. The hub is a central device. It's a centralizing device which brings the media segment together and interconnect the devices within a single network. This could be an organization network connected through a central device, in this case the hub. You link the computers to the hub and to each and every network device, whether it's a printer, whether it is a computer, whether it's a scanner, you link them together through the central device. So that way you are able to expand a single network, because each other time that you want to add another computer to the network, you'll set it up in a particular office, then have a cable connecting all the way to the central device, which is the hub. And each other time you want to add a computer, you can do so. You can even remove a computer from the network. Or you can connect this set of computers within the network with another set of computers by interconnecting these hubs together, such that you have multiple network segments. That way, this is act as a networking device that can be used to expand a single network. And the way it functions depends on the kind of hub, because there are three types. We have a passive hub, we have an active hub, and you also have the intelligent hub. The passive hub is a dumb device. It does not perform any functionality to the network signals. It only allows the signals to pass through to a particular network device. But if it is active in the sense that the active hub will pick the signals, amplify them or regenerate the signals, then broadcast to all the computers that are connected to this particular hub. But only the computer whose destination address matches with its address is going to decode that message. So the active hub regenerates the signals, and to regenerate the signals is to re-energize them so that they can be able to travel a longer distance, or they can be able to move a longer distance within the transmission media. They don't suffer from the network or the signal, the strength of the signal losing the strength along the transmission media, which is referred to as attenuation, and therefore by re-energizing them they are able to move a longer distance. But with the intelligent hub, it does the same by picking the signals, amplifying them and retransmitting them only through the destination path. If the message was meant to a particular destination, they'll only forward them through that path. That way, this particular device is able to expand and manage a single network. That's why it falls under the category of networking devices. Then we have the second network device, which is the repeater. The repeater, as the name indicates, it repeats the signal and thereby allowing to extend a single network. A single network in the sense that if the signal would move up to a particular distance of 100 meters, then by repeating the signal and retransmitting it, you are able to extend the physical length of the network such that it can be able to cover 200 meters if the initial distance was meant to be 100 meters. Because as the signal travels along the media, whether it is a digital signal along the cable or it's a wireless signal, even my voice, somebody who is 1 kilometer cannot hear what I'm saying because the signal keeps on weakening and weakening. Once it gets to this point, it cannot travel any further. But if it meets a repeater, the repeater will repeat the original bit pattern and then retransmit to another, for another distance, let's say 100 meters, before it meets another repeater, and the process continues. Thereby, you are able to expand a single network. So repeaters are also network devices which are meant to manage a single network and expand a single network by the fact that they are able to allow the signals to cover a longer distance other than the original permitted distance that the signal would travel, as it emits other factors like environmental factors, noise, resistance, and other kind of effect that would interfere with the signal as it travels along the transmission media. So they are installed on the link so that they can increase the physical length of a network by re-energizing the signals again and retransmitting them over a longer distance. And that way, the devices that are within the region they can be able to communicate effectively. We also, on the repeaters, they have some advantages and disadvantages. They have an advantage that they allow easy expansion of the network, especially when you want to enlarge your network so that it covers a large area. And they have a very little impact on the speed of the network because they don't affect or cause delays even as the repeating of the signal is taking place. They have a very little impact, so the speed is uniform and they allow connection between different medias. You don't have to use one transmission media at a time. You don't have to use wired transmission or wireless transmission. You can have a mix of the two in the same network. But the only disadvantage is that they don't provide addressing information. So when they are repeating the signal, they actually broadcast. So they don't send to specific devices. And they cannot connect two different architectures. They have to be one network architecture all throughout. They do not help in to his congestion problem because once they broadcast, whatever they receive is what they said or they said back to other sections. So whether there is much data or less data, unlike the bridge which is able to filter network traffic, this one deals with what it receives and retransmits, whether it causes congestion on the network or not. It's not able to perform a network management in terms of data traffic. And then the number of the repeaters in the network, they are limited, although they also vary again depending on the interference within that particular area that data is being transmitted. Then we have the bridge. The work of the bridge is to filter network traffic, and once they filter network traffic, they are able to perform network management or data management in terms of where they are meant to be within a network. This is a single network, but it's divided into two segments. You have segment A and segment B. In between here, there is a bridge. So how does the bridge perform network management? By filtering out data. The bridge looks at the destination address of the data from the source computer, let's say computer 1. If the destination address is on the next segment, this other side, then the bridge will allow the data packets to come to this side. But if they are from this side to the same side, then they are not allowed to pass through here because they will cause a lot of data congestion on this other side, and therefore there will be a lot of data traffic which will slow down the network. That way, this particular network device is able to perform this function of filtering data by determining whether the data packets are going to close to this other side or not. It's classified as a network device because it manages a single network. It has some advantages and disadvantages also, just like the repeater. Although the good thing about it is that it is able to determine the addressing of the data such that it is able to manage what is being transmitted and what is allowed to close over to each segment. Thereby, you have less data traffic, which is necessary for each segment within the network. Then you have a switch, which is also a network device. It's also a centralizing device where you can use it again to interconnect devices within a central point. The computers within a particular building, like all of these buildings, they are connected through a central device, which is the switch that connects to the server. And by so doing, the computers within a network, they're able to share resources. And that way, it also allows expansion of a single network. All those network devices, they are referred to as networking devices, and they are meant to connect a single network. So there's a mix-up of these advantages that I had earlier mentioned. These are the advantages of the bridge. Once you connect the bridge all together, then you're able to filter data traffic, as I've just mentioned, and then you're able to to control which data gets to which segment and which one is not meant to do so. Then the last subcategory is the internetworking devices. These are the devices that we use to interlink different networks. Network A and network B can be connected and managed together through the router, the brouter, and also the gateways. They are referred to as internetworking devices because they are used to interconnect or join two separate networks, which are referred to as internetworking connectivity. We look at the brouter, the routers, and the gateway, each at a time. And in this particular representation here, you may have different networks at different sections, and then you interlink them together by using the router such that you can select the path from a particular computer to another computer, given that there are different routes that data packet can take through to get to the destination. So as the name indicates, the work of the router is to route or to give direction to data packets, which are the messages that you are transmitting. A network is an interconnection of different routes, just like the road. You can take a different path, another path, but all of them are getting to the same destination. You may take a longer route or a shorter route depending on different factors. The same way the router does that. It chooses the best route that is effective or that is best for a particular data transmission, and it will guide the data packets towards that particular path. It's a internetworking device because the data packet can move from one network to another network within an interconnection of different networks. Then we have a brouter. A brouter is a two-in-one device. It connects it's a router and a bridge. And just like you have said with the routers and the bridge, this particular device manages different networks. This is one network, this is another network. It interconnects the two networks together and performs some network management depending on the kind of data that it receives from different sources. The internet is a connection of networks, or you may have more than one network connected together, like in this presentation here. If you connect these networks together and you manage them with a brouter, then when the brouter receives a packet that is meant to move to the next segment, it will function as a bridge. But if it gets a packet that is not bridgeable, or which does not require to be forwarded to the next segment, it will act as a router by determining which path is suitable for that particular data. And that way, it will be able to direct the data packets to a particular direction, given that, or depending on which route is best, which route is most suitable for a particular transmission. So it will either act as a router or as a bridge, depending on the data packet that it receives. If it receives a packet that is routable, it will choose the best path. Otherwise, it will act as a bridge by forwarding it to this segment or not, depending on what it receives. That is the brouter, which acts as an internetworking device. Then, if it acts as a router, again, the router has different advantages and disadvantages within the network. But the main advantage of the router is that it can be able to choose the best path, which is the most important because the message will take a lesser time in the transmission media. Therefore, it will cause less congestion in case other devices wants to transmit within the network. It chooses the best path for the data packets and transmit them through that path, and therefore it's able to reduce network traffic by forwarding data to the right direction, which is the most important for any network. And then lastly, we have a gateway, which is a protocol converter. The gateway is an internetworking device because you can connect it through multiple networks. You can have network A, network B, and other networks linked together through the gateway, which is the entry point and the exit point of different networks, such that it performs a protocol conversion. A gateway is a protocol converter, meaning that before the messages gets out of the network, they are converted into standard protocols so that the rest of the network can understand. The same case applies even to the entry of data transmission. Data packets are converted into standard protocols and before being forwarded to other network segments. And that way, you are able to manage different networks by use of a gateway as an internetworking device. There are quite a number of network devices, so many of them that exist, but the choice of one depends on the size of the network and the purpose as to why you are connecting up the network within the network link or the network that you are setting up. So that brings us to the end of our lesson. We stop there, and once we meet in the next lesson, we'll be able to look at where each of those network devices applies within the OSI layer or the Open System Interconnection model. Thank you.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.